That's fine. Thank you, though. Okay, so guys, for our collisions, so for elastic collisions, inelastic collisions, here are our equations. M1v1 plus M2v2 equals M1v1 prime plus M2v2 prime. This side of the equation, this is used for the after collision. Those little prime are the little apostrophes. That just means the new velocities after the object has collided. So for the problems that we're doing, inelastic collisions, okay, the objects are going to hit each other and bounce off. They're never going to stick together. Perfectly inelastic collisions, which are what we are dealing with, the objects will stick together. So at that point, all right, it becomes like this whole new object that moves as one. And so they don't have different separate velocities. They move at the same velocity. So in these problems, the biggest thing for us is probably going to be just figuring out who is what and where the objects are and how we're going to go about this. So the easiest thing that I have found is coming up with a drawing. And then after the drawing, all right, putting our values under it, and then put the equation under it, substitute our values in, and go from there. So we have a 1,500 kilogram car that is traveling 15 meters per second to the right. Collides with a 45 kilogram truck that is initially at rest. The car and truck wind up sticking together after the collision. What is the final velocity of that two vehicle mass? So what you guys are going to want to do, okay, and everyone should be doing this. We have our before, and then we have our after. So beforehand, we have a 1,500 kilogram car that is moving at 15 meters per second. It says it hits a truck that is initially at rest. That truck was 4,500 kilograms. Now, since it doesn't have a velocity, right, the velocity is 0, I can just kind of write here, inside the little guy, 0 meters per second. Or write it next to it. That's fine. So after these two things it says in the problem, they wind up sticking together. So you have the one object, right, the truck, and the car. The masses don't change. So it's 1,500 kilograms and 4,500 kilograms. And they're moving now together with a certain velocity. VF is what we are looking to find. So now, if you guys do this how I'm showing you, this becomes not difficult. Figuring out what kind of collision it is, all right, especially after the drawing. Since they got stuck together, okay, that's inelastic. I would just say definitely always kind of write it next to so you know what equation you're using. After you figured out the equation, what you should do is kind of underneath your drawings, write out the actual equation itself. So here we have M1 V1. All right, so that's like the momentum of the first object, plus M2 V2, which is the momentum of the second object, equals M1 plus M2 times VF. And now, after you've done the drawing and labeled everything, now it's, okay, put everybody in the spots they need to go in. M1 is what? 1,500. V1 was 15 plus 4,500 times, what is this velocity again? 0. Equals, the masses didn't change, so that you're going to do this. You're going to add 1,500 and 4,500 together, and that value gets multiplied by VF, but we don't know it yet. So now what I would tell you guys to do is to simplify. Okay, multiply everybody out. This comes out to be 22,500. Anything times 0 is 0. Equals, adding these two values together, you get 6,000. So it'd be 6,000 times VF. All right. Then what you would do, all right, you would add these two values together and then divide by the guy in front of the VF over here. That is what you're solving for. But for us, since we are solving for the VF, all right, and this is 0, 22,500 plus 0 is 22,500 equals 6,000 VF. To get VF by itself, what do? You divide both sides by 6,000. And the final answer should come out to be, if you calculate it out, 3.75 meters per second. Okay. So the next one, you have a marble sliding to the right, makes a head-on collision with a marble that's moving to the left. After the collision, the first marble moves to the left at this speed. What is the velocity of the second marble? Okay, so since another object is moving right to the left and they give us another velocity, that is telling us that, all right, it gave us a velocity after the collision, and we're looking for the velocity of the second marble after the collision. So they didn't stick together, so we're looking at an elastic equation. So I'm writing elastic next to the side here. I'm going to write my little before and after. Are you following? Thank you. So let me do the drawings here. The first object, 0.015 kg marble sliding to the right. So the beforehand, we got this marble, 0.015 kilograms, and it's moving to the right. So anything that's going to the right is positive value. So we have 22.5 meters per second. It makes a head-on collision with a marble that is 0.15 or 0.015 kilograms, and it is moving to the left at 18 meters per second. So if it's left, we're going to just say we're going to tell you that it's negative. So this is what's going to happen. They're going to hit each other, and then they're going to bounce off because it says the first marble now moves to the left after this collision. So after the collision, that is not a 2. It should not be there. The mass didn't change, but this guy's velocity did. It is now this negative 18 meters per second because it's telling us it moves to the left. The other marble, again, has the same mass. Mass doesn't change. We need to find out this, the velocity of the second object after the collision. Some or v2 prime. Okay. Once we have the drawing, all right, once you have the drawing done, what should you do? Write the equation, all right, underneath it. So we're looking at the elastic equation, which is m1v1 plus m2v2 equals m1v1 prime plus m2v2 prime. m1v1 plus m2v2 Once you have those under the drawing, you just match everybody up. Mass of the first guy is this, 0.015. What is its speed or velocity that's moving at? 22.5. Bring down the plus sign. Mass of the second object, 0.1 or 0.015 times negative 18. Equals this dude here, this M1 V1. So 0.015 times its new speed, which is negative 18. All right, the negative 18 we figured out because it's moving to the left. And if it's moving to the left, we're giving it a negative value for its velocity. And now multiply these guys. So the second mass was this 0.015 times V2 prime. So that's what we don't know. So multiply everybody out. That'll be your next step. Multiplying these guys, you're going to get a 0.3375. Multiply these two together. You're going to get a negative 0.27. Multiply these dudes out. You're also going to get a negative 0.27. And over here, nothing changed. You still have your 0.015 V2 prime. Okay, so again, I'm doing this step by step. Next thing you should do is add these two values together. When you do, you're going to get 0.0675. That equals negative 0.27 plus our V2 prime. Now, we got to get rid of this. To get rid of this guy, add a positive one to both sides. If this wound up being a positive value, you would subtract it. But since this is negative, to cancel this guy out, you're going to add yourself a little 0.27, add yourself a little 0.27 to both sides. And so on this end, you're going to get a positive 0.3375. And now that's going to equal your what's left over here, this 0.015 V2 prime. And again, to get v2 prime by itself, now you got to divide both sides by this 0.015. So v2 prime equals, comes out to be a positive value, 22.5 meters per second. And since it's positive, that's telling us this dude is going to the right. All right, let's set up the next guy. So this one's a pain. This one's worded a little weirdly, but a grocery shopper. All right, so I go to the store. I take this 9-pound bag of rice, and I toss the bag of rice into a shopping cart. So the bag hits the cart, moving at a speed of 5.5 meters per second. Now, what was the cart doing? Was it at rest? Yes. So it's going to have a velocity of 0. The bag of rice would have a velocity of this 5.5. Now, assuming that I shoot better than I do over here, all right, I'm getting the bag of rice into the cart. Would you say that they bounce off of each other or stick together? Stick together. So if that is the case, all right, we're looking at an inelastic. Bless you. We're looking at an inelastic collision. So again, what I'm doing is I'm making my drawings here so that beforehand, I have a 9-kilogram dude, and I'm tossing this thing at a speed of 5.5 meters per second. And it's going to hit the shopping cart that was at rest. So we have 18 kilograms, and its velocity is 0. After they collide, they're going to be stuck together and move as one whole new thing, new object, new system, whatever, and they're going to move together at the same velocity. So here, the mass of the first object, the bag of rice, still 9 kilograms, and the shopping cart here is this 18 kilograms. Next step should be to do what? Since write the equation underneath everybody. And that way it's just easier, so you can just flop everybody in. All right, so we have what? We have M1 V1 plus M2 V2 equals M1 plus M2 times VF. And now plop the numbers. You're gonna take the numbers and go through and solve. So you're gonna have 9 times this 5.5 plus 18 times 0 equals 9 plus 18 times VF. And then you guys will go through and you will solve. Okay. So I gave you the full, gave you a good setup here. Your guys' job is going to be to go through and finish that one off. Okay. Now, the next problem here is number 4. Now, number 4, in this case. All right, we got a 4 kilogram raft that's moving to the right. It makes a head-on collision with a canoe moving to the left. Afterwards, the raft is going to move to the left at a certain speed. What is the velocity of the canoe? All right, so again, that's a pain in the butt. But if we draw it out, we got a 4 kg raft. So beforehand, the raft is going what direction? To the right, so it's positive, and we're saying it's moving at 6 meters per second. The canoe is moving to the left, so we're going to call it negative 12 meters per second. And it has a mass of 16 kilograms. Afterwards, it says that the raft is now moving to the left. So this guy was our raft. Now he's going to be moving to the left. Still the same mass. Now this thing is moving to the left at 22 meters per second, 22.7. So this one would be a negative 22.7. And okay, well, do we know what direct? We don't know what direction the canoe is going to be moving in. The mass, we know it doesn't change. And so we're looking for V2 prime. We don't know. And we don't know whether it's left or right. So if you go through and we solve this, and as we go through and we solve it, if V2 prime is negative, then we can tell you that the canoe is also still moving left. If it's positive, well, that means when it hit, it bounced backwards a little bit, and now it's going to the right. Okay, so once we know that, what kind of a equation is this? If they didn't get stuck together, is that elastic or inelastic? If they don't stick together. If they don't, that's elastic. Yep. So it's telling me that, all right, that's elastic. And now I'm going to write the equation underneath that. So that's M1 V1 plus M2 V2 equals M1 V1 prime. And again, that little apostrophe just means the new velocity, all right, or the velocity after the collision, plus M2 V2 prime. Once you have that, now let's plug everybody where they need to go. So we have 4 times 6 plus the mass of this guy, which was 16, and timesing it by a negative 12, which equals mass of the raft, which was still that 4, and its new speed is 22.7 to the left, or this negative 22.7, plus mass of the canoe, which is still that 16, times V2 prime, the only thing we don't know. Next step, multiply your stuff out, and then add, simplify, subtract, divide. 4 times 6, 24. 16 times a negative 12. So negative 192. Then we have 4 times negative 22.7, less than 100. I don't know, we'll call it, right, it should come out to be, I think, roughly this, negative 90.8, I believe. And we add that, right, to the 16 times V2 prime. All right, again, I'm showing this one step by step. Simplify it out. You get this negative 168 equals this negative 90.8 plus 16 V2 prime. Getting rid of the negative 90, add that negative 90 to both sides. When you do so, you're going to get, still have a negative over here. It's going to be negative 77.2. And that's going to equal this 16, nope, not VF, V2 prime. Divide both sides by 16. So V2 prime will equal negative 4.825. So since it's negative, what direction is the canoe what direction is the canoe going to be moving? Is it still moving to the left, or did it hit, bounce, and move to the right? It's still moving to the left. All right, it's still moving to the left at this velocity, all right? So this is basically saying left at 4.28. So it's still moving in the same direction, but quite less. Okay. Cool beans. The next one, you have an arrow, 0.25 kilogram arrow with a velocity moving to the right. It strikes a target that's not moving. Now, the target and the arrow move backwards together. So that would be an inelastic. So let's just draw that guy out for us here. All right, so the first object is at 0.25 kilograms, and it's moving at 12 meters per second to the right, and it strikes a target that's 6.8 kilograms and was not moving. So they didn't give us any value here, so also you're assumed to is not moving. Plus, most of the time you're doing archery, right? You're usually doing it at a stationary target, unless you're hunting or something like that. But even then, hopefully you're usually like trying to take the shot at like an animal right when it's not moving. I don't know. Don't really hunt. But
would you go hunt it?
Would I? Possibly.
Yeah, that's how I feel.
All right, so they're gonna be like stuck together. It wasn't a bad circle. I mean, besides this little spot right here, all right, it was solid. Same masses, 0.25 kilograms, and the 6.8 kilograms. Now they move together at some kind of velocity, VF. All right, so your step here would be to write the equation underneath for the inelastic and complete it. And during this one, the bucket's lying on its side. You kick a ball into it, so they're going to move together here. All right, so let's draw this one out. You have a a ball that's at 0.40 kilograms. It's kicked and is moving to the right at 8.5 meters per second. It strikes a bucket. The bucket, it's hollowed out a little bit, so it's not as heavy. 0.15 kilograms, and it's not moving. So we're going to say it's 0 meters per second. If you kick the ball into it, they're both going to be moving together. Masses don't change, so you still have the 0.40 kilograms and the 0.15. And they are moving together at a certain velocity, which you're solving for, okay? So this one is also inelastic. So again, you write the equation underneath, put your numbers in. All right, multiply, add, subtract, divide to get your final answer. All right, guys.